Hello everyone and welcome back to another episode of Math with Dr. War. Today's lesson is solving the systems of nonlinear equations. Let's begin. So I have two equations here. Now my first equation is 3x minus y equals to 1. This is a line. And my second equation is x squared plus 2y equals to 5. This is a quadratic equation. I'm going to be using the method of substitution to solve my system of nonlinear equations. Now, because it's a substitution method, I have to decide, will I start with equation 1 or equation 2? Since I have a quadratic and a line, it's best to start with my quadratic. It would be easier. So I'm going to start with x squared plus 2y equals to 5. Now notice I have two different variables and I need to rewrite one of these variables in terms of the other. So I'm going to go to my equation number 1, which says 3x minus y equals to 1. And I'm going to have to decide which variable will be the better choice. Now your better choice will always be when you have like a 1y or 1x or 1a or 1b, whatever variables they give you. So this here with the x is no good because it has a 3x, which means you will have to divide everyone by 3, so we're not up for that today. Now I noticed that this is a negative y. You always want your variable to be positive. So an easy way to rewrite this is I'm just going to switch the places of the y. So I'm going to take the negative y to the right, and I'm going to take the 1 to the left. And remember, whenever you switch places, the signs change. So the 3x is going to stay. When the 1 comes over, it becomes negative 1. When the negative y goes to the right, it becomes positive y. So basically, I rewrote my equation in terms of y. Y equals 3x minus 1. And I'm going to take this y and replace it in my equation 2. So I have x squared plus 2. Okay, what my y is 3x minus 1 equals to 5. So notice now I have all of the same variables. Everyone is an x. Okay, let's get rid of the parentheses using the distribution property. I get x squared plus 6x minus 2 equals to 5. Remember, to solve any quadratic, it must equals to 0. So I'm going to subtract 5 from both sides. I get x squared plus 6x minus 7 equals to 0. And this is a simple, basic trinomial factoring. I'm going to open my parentheses. X squared would be x and x. My product is a negative, which means I'm going to have a plus and a minus. Now I'm looking for two numbers that when I multiply, I get 7, but when I subtract, I get 6. The only two factors will be 7 and 1. And because I want a positive 6, because 7 is the bigger number, it's going to go with the positive, and the 1 is going to go with the minus. Now let's solve for x. So I have x plus 7 equals to 0. Let's draw a line here, and then I have x minus 1 equals to 0. So solving for x, I would subtract 7 from both sides. So this would x be equals to negative 7. Or you can do it the simple way. I just have x equals, now here my constant is negative 1, therefore I'll write the opposite, it's positive 1. So I found my values for x. Now I have to find my values for y. So I'm going to go right back here to this y equals to 3x minus 1 to find my values for y. So let's start with when x equals to negative 7. So I'm going to use y equals to 3x minus 1. Wherever I see x, I replace it with negative 7. This would give me negative 21, take away 1, which has a value of negative 22. So when my x value is negative 7, its associated y value would be negative 22. Okay, let's see what happens when x has a value of 1. So we have y equals to 3x minus 1, 3, now x is 1, minus 1, 3 minus 1, let's put the minus there, is 2. So when x is 1, y has a value of 2. So my solutions for my system of nonlinear equations is going to be -7, -22, 1, 2. And that's my answer. Now, if you want to check, you can. I'm going to check with the 1 and the 2. 1 squared is 1, plus 2 times 2 is 4. And guess what? That gives me 5. And if I check with number 1, 3 times 1 is 3, minus 2, I get 1. So 1 and 2 works. You can try with the -7 and the -22 as well, and you will see that they are also correct. Now, you're going to have two solutions because we have a quadratic and a line. So remember, a quadratic is a U. And because it's positive, it's an upward facing U. And then you have a line. And notice that with a quadratic and a line, you're going to intersect at 2 points. So I know that I'm going to have two answers. Okay, here's another one. I have x plus y squared equals to 6 and x squared plus y squared equals to 26. So my first equation is a quadratic and my second equation is a circle. So who should I start with? It's better to start with the circle. So we're going to start with x squared plus y squared equals to 26. Now let's go to number 1, which says x plus y squared equals to 6. So you're like, okay, who would be the better variable to rewrite this in terms of? You got it right, the y squared. Because you over here, you see the y squared already? Yes. So I will want to minus x on both sides, or you can do that arrow thing I did. Take it over to the other side. Y squared equals to 6 minus x. So we can rewrite y squared in terms of x. So here I have my x squared plus, now because it's a positive, we can just dump that there because we know that y squared is 6 minus x equals to 26. I'm going to rewrite this in standard form. So this will be x squared minus x plus 6 equals to 26. Now remember, to solve this, it must equals to 0. So we're going to subtract 26 from both sides. So I have x squared minus x, that's a square, minus 20 equals to 0. Again, we can factor this. It's very simple. You're going to have x and x. Okay, we have a negative again, so we're going to have a plus and a minus. Looking for two numbers that when you multiply, you get 20, and when you subtract, you get 1. 4 and 5 would work, but we want a -1. Therefore, the 5, which is bigger, would be with the negative, and the 4 with the positive. So I have x plus 4 equals to 0, and x minus 5 equals to 0. So x has a value of -4, and x has a value here of +5. So we have two values. Okay, we got to find a corresponding y. So let's start. When x has a value of -4, let's find our y. So you have y squared equals to 6 minus x. So this will be 6 take away -4. So this is actually 6 plus 4, which is 10. So y squared equals to 10. But we don't want y squared, we want y. So you're going to have to take the square root of both sides. Now this will give me y. And remember, from completing our square and using the quadratic formula, this would be plus or minus square root 10. So here, for our value for x, you're going to have two values. So when x is -4, you're going to have a value of either positive radical 10, or when x is -4, you're going to have a value of negative radical 10. Okay, let's find when x is 5. So when x is 5, we have y squared equals to 6 minus x. That would be 6 minus 5. So y squared equals to 1. But we don't want y squared, so we're going to have to take the square root of both sides. This will give me y equals plus or minus, and the square root of 1 is 1. So when x is 5, I have a +1 for the y, or when x is 5, I have a -1. So my answer for this, a circle and a quadratic, I have 4 values. So I have -4 with the radical 10 positive, -4 with the negative radical 10. I also have the 5 with the 1 and 5 with the -1. So I have 4 answers, or 4 solutions. And the reason for the 4 solutions, remember I said your second equation was a circle. And your first equation is a quadratic. Okay, so my quadratic doesn't look so cute. Let me erase that. I am not a very good artist. Let's try that again. So I have a circle and a quadratic. Okay, doesn't look cute, but okay, let's try that again. Take 3. Here's my circle, and there's my quadratic. Yes. Notice that your quadratic is intersecting your circle at 1, 2, 3, 4 places. Therefore, you should have 4 solutions. Okay, last one. This one is a lot of work. So I have 2x plus y equals to 5. That's my first equation, and it's a line. And then I have x squared plus y squared equals to 50. So I have a circle. Okay, what do you think I should start with? Yeah, you're right, the circle. So we're going to start with the x squared plus y squared equals to 50. Which means we have to rewrite our line. So I have 2x plus y equals to 5. So who should I rewrite? Oh yeah, you got it right, y. No one wants to mess with that 2 because you have to divide and yada yada. Okay, so the y is positive, so that's fine. So we're going to just, therefore y has a value of 5 minus 2x. So we have x squared plus, now our y is 5 minus 2x, but we have y squared, so you have to square it, equals to 50. Now this is why I said this was a little bit of work, because we need to FOIL this. So 5 minus 2x all squared means that 5 minus 2x have to multiply itself twice. So that would give me 25 minus 10x minus 10x plus 4x squared. So if I write that and combine like terms in standard form, it would be 4x squared minus 20x plus 25. So this would be x squared plus 4x squared minus 20x plus 25 equals to 50. Combining my like terms, I'm going to end up with 5x squared minus 20x plus 25 equals to 50. But to solve any quadratic, it must equals to 0. So we're going to have to subtract 50 from both sides. So I end up with 5x squared minus 20x minus 25 equals to 0. Now, when I look at my quadratic, I notice I have a 5. Oops, here's my 2. That's supposed to be 20. My 20 and my 25. And I can factor out 5. So if I take out the 5, I end up with x squared minus 4x minus 5 equals to 0. And if I factor what's inside the parentheses, I'm going to end up with, okay, x here and x. Again, we have a negative, so a plus and minus. I'm looking for the factors of 5 that when I subtract would give me a 4. That would be 1 and 5. But I want a negative 4. So the 5 goes with the negative and the 1 goes with the positive. And again, you can check. I always tell my students check because they always make a little error. Now if I multiply 1 with negative 5, I get negative 5. And if I add 1 with negative 5, I get negative 4. So always check your factors if you think you're going to make an error. Okay, let's solve. X plus 1 equals to 0, which means x has a value of negative 1. And I have x minus 5 equals to 0, which means x has a value of positive 5. So now we have to find the corresponding y values. Okay, when x is negative 1, the y value, which we're going to get from here, we have y equals to 5 minus 2x. So this will be 5 minus 2 times negative 1 So I have 5 plus 2, which will give me 7. So when x is negative 1, y has a value of positive 7. Okay, let's see what happens when x is 5. So we're going to use y equals to 5 minus 2x. That will be 5 minus 2, and x unfortunately is 5. So this is 5 minus 10, which has a value of negative 5. So when x is 5, y has a value of negative 5. So this will have two solutions. So my solution here, let's put it in this box, is going to be negative 1 comma 7, or it's going to be 5 comma negative 5. This will have two solutions, and how do I know that? I have a circle and a line. So if this is a circle and I draw a straight line, notice it only intersects two places. So I'm going to only have two solutions. And again, if you want to check, you can. So I'm going to do this manually. 2 times 5 is 10, and 10 minus 5 is 5. 2 times negative 1 is negative 2, and if you add 7, you get 5. So it worked for the first one, and then if you want to check the second one, you can. If x is 5, 5 squared is 25, and negative 5 squared is 25, and 25 plus 25 is 50. And then over here, negative 1 squared is 1, and 7 squared is 49, and 1 plus 49 is 50. So it works out. I hope this video has been helpful. Good luck in your examinations, and remember, please like, subscribe, share. Have a great day.